Okay, so today we're going to be talking about 8.2, but before we get there, we're going to go over one of the problems from the 7.2 homework assignment, number 9. We have f of x equals 3 times 1/4 x minus 2 plus 1. Okay, now, is this exponential growth or decay? Growth, remember your b value is greater than 1, and your decay, your b value is between 0 and 1. So looking at this number right here, what have we got? Looks like we have a decay. So our graph should look something like this. Okay? Unless this rotates it, but I don't have a negative here, so I'm good. And I can also look at this and see that I'm going to have a vertical stretch by 3. That's what this means right here. So vertical stretch by 3. Okay. I'm also going to have a shift horizontally by 2 to the right. That's what this guy tells me up here. It's up high, horizontal. So shift right by 2. And over here, this plus 1 means that I'm going to shift up 1. And one of the things that this guy shift up 1, that this guy tells us is where our asymptote is going to be, or where our range is going to be. So our asymptote is going to be at 1, which means it'll approach 1, it'll go towards it, but it'll never hit it. So asymptote at y equals 1, which means our range is that y has to be greater than 1. And you'll see that when you look at the graph. Domain is all reals. Again, more than likely it's always going to be all real numbers. It's your x values. What does it do on your graph? The only time when your domain is affected is when you have a problem that has like an x in the denominator of equation, or when you have an x under your square root. That's the only time when your domain's really going to be affected. I mean, there's other times, obviously, but for the purposes of this class and the math that we're doing, really, this is the only times when you're going to have, okay, well, your domain cannot equal 5, or your domain cannot equal 4. Because, again, you can't have a 0 in your denominator, and you can't have a negative underneath a square root sign. You can have a negative under a cubed root sign, but not a squared root sign. So in regards to the domain, more than likely it's going to be all reals. In fact, for all these problems, it's always going to be all reals. Just because you're doing an exponential growth or decay model, you are never going to have an x in your denominator or an x under your radical. And for range, I'm still having some questions on range. Really, it has to do with where your graph lies on your y axis. Is it in the negative y's? Is it in the positive y's? Is it at y equals 0? Okay, and again, that comes with practice, and you guys will start to see those a little bit easier as you go along. Okay, so let's look at our table xy and plug some numbers in. So I'm actually going to start this one at 0. And the reason why is because these are going to get to be pretty big numbers. And it's okay to change the numbers that you plug in. Excuse me. You can start at -2, and in fact, why don't we do that? Because then I can just show you what's going to happen. So -2, -1, 0, 1, 2, 3, 4, and 5. Okay, I know these are a lot of numbers, but you'll see why we're going to do that in a minute. So I'm going to plug in 3 to the 1/4 to the -2 minus 2 plus 1. And I get 3 to the 1/4 to the -4 plus 1. Well, whenever I have a negative with my fraction, I have to flip-flop this guy. So I'm going to get 3 to the 4th, 4 to the 4th plus 1. Okay, well, 4 to the 4th is 256. It's 4 times 4 times 4 times 4. Okay, you get 256, and then you have to multiply that by 3 and then add 1. So it's going to be a really big number. Okay, so let's keep going because I'm not going to figure that one out. Okay, and then we have, and if you have a calculator, you're more than welcome to do that right now. 3 to the 1/4 to the -1 minus 2 plus 1. I get 3 to the 1/4 to the -3 plus 1, which is 3 times 4 cubed plus 1. Well, 4 cubed, that's 4 times 4 times 4, which is 64 times 3 plus 1, which is going to give me 193. Again, really big number. I'm not going to graph that. And then I have 3 to the 1/4 to the 0 minus 2 plus 1, which is 3 to the 1/4 to the -2 plus 1. 3 times 4 squared plus 1. Let's 16 times 3, which is 48, plus 1 is 49. And then I have 1, so 3 to the 1/4 to the 1 minus 2 plus 1 is 3 to the 1/4 to the -1 plus 1, which is 3 times 4 plus 1, which is 13. Getting a little bit better now. And then I have 3 times 1/4 to the 2 minus 2 plus 1. Oh, yes, we got a 0. 3 to the 1/4 times 0, or to the 0 is just 1, so I get 3 plus 1, which is 4. Okay, and then I have 3 to the 1/4 to the, I'm sorry, we're at 3 now, right? 3 minus 2 plus 1, so I get 3 times 1/4 to the first plus 1 equals, well, this is 3/4 plus 1, which 1 you can also write as 4/4. So 3/4 plus 4/4 is 7/4. And then I have 4, 3 to the 1/4 to the 4 minus 2 plus 1, 3 to the 1/4 squared plus 1 is going to give me 3 times 1/8. I'm sorry, 1/16. Plus, well, we can change this into 16ths by multiplying top and bottom by 16. And 3 plus 16 is 19/16. And then 5, so on and so forth. You're going to keep getting some fractions. So let's look at these guys right here, because those are a little bit easier to graph. Oops. Okay, so that graph's going to be a little crooked. You got the idea. So let's graph the ones that are a little bit easier to graph. Let's graph 1, 13, 2, 4, 3, 7/4. So 0 is up at 49, which is way up here. And then 1 is at 13. So we'll put that up here. And 2 is at 4. 3 is at 7/4, which is going to be here. 4 is at 19/16. It's going to be here. Okay, so your graph is going to look really big, but it's approaching 1. It's never going to quite hit it, okay, because that's where your vertical asymptote is. So if you have this graph crossing your x-axis, it's going to be wrong. It doesn't cross it. There's a vertical asymptote at y equals 1. Okay, so that's your graph. Again, if you have something like this where you're using really big numbers, don't worry so much about labeling your x-axis or your y-axis, but I would label each individual point so that you can show me, okay, I know what this means. This is 13, and this is 2, 4, and this is 3, 7/4, so on and so forth, so that I know that you have the general idea of where your points are going. And that's it for that problem. Okay, it was a long one. You had a lot of work to do, but really you have to check and keep track of each piece when you're plugging them in, and then you guys should be fine with these.